There is something deeply human about the idea of an edge. From the moment our ancestors began exploring the world around them, every journey eventually came to an end. Rivers met the sea. Forests opened into plains. Mountains gave way to valleys. Even the horizon, though forever out of reach, promised that if someone could only travel far enough, another landscape would eventually appear. Our understanding of reality was shaped by places with boundaries, and over time we came to assume that boundaries were not merely common, they were inevitable. It is hardly surprising, then, that when humanity first began asking questions about the universe, we imagined it in exactly the same way. However vast it might be, surely it had to end somewhere. There had to be a final star, a last galaxy, a distant frontier beyond which there was simply nothing left to see. For centuries, that assumption survived almost unquestioned. Ancient civilizations imagined the heavens as enormous domes stretching above the earth. Beyond them lived gods, eternal darkness, or realms forever inaccessible to ordinary people. Those ideas eventually disappeared as science replaced mythology, but the expectation remained remarkably unchanged. The universe was still imagined as a place that could, at least in principle, be completely explored. Every major scientific breakthrough seemed to reinforce that belief. When Galileo Galilei first pointed a telescope toward the night sky in 1609, he revealed mountains on the moon, countless invisible stars, and 4 small moons orbiting Jupiter. Overnight, the heavens ceased to be perfect and unchanging. They became physical places, governed by the same natural laws as the earth beneath our feet. 2 centuries later, astronomers built larger telescopes and discovered that the Milky Way was far greater than anyone had imagined. Then came Edwin Hubble, whose observations in the 1920s transformed our understanding once again. The faint smudges scattered across the night sky were not nearby clouds of gas, as many had believed. They were entire galaxies, each containing hundreds of billions of stars. Suddenly, the universe became almost unimaginably larger. Yet, something curious happened. Every time humanity extended its vision, the horizon retreated. Instead of approaching a boundary, we uncovered another layer of reality waiting beyond the previous one. Every new generation inherited a cosmos larger than the last. The edge never appeared. It seemed to move away just as quickly as our technology advanced. At first, astronomers regarded this simply as evidence that the universe was much bigger than expected. If larger telescopes revealed more distant galaxies, then perhaps even larger telescopes would eventually reveal the end of everything. It was a reasonable conclusion. It also turned out to be profoundly mistaken. The true obstacle was never the size of the universe. It was the nature of information itself. Every piece of knowledge we possess about the cosmos has reached us in exactly the same way. Whether we observe the moon, a nearby star, or a galaxy billions of light years away, we rely on one messenger and one messenger alone. Unlike explorers crossing oceans or climbers reaching mountain summits, astronomers never travel to the objects they study. The universe must come to us instead. Every observation begins with photons that have crossed enormous distances before ending their journey inside the mirror of a telescope. That simple fact changes astronomy in a way unlike any other science. A geologist can walk directly to the rocks they wish to examine. A biologist can observe a living organism in the present moment. A chemist can repeat the same experiment thousands of times inside a laboratory. Astronomers have no such luxury. They cannot visit distant galaxies. They cannot repeat the birth of a star. They cannot witness the early universe unfolding again. For light that may have begun its journey millions or even billions of years before the Earth itself looked anything like it does today. This means that every telescope, regardless of its size or sophistication, is doing something surprisingly different from what most people imagine. It is not simply looking farther into space, it is looking farther into the past. This idea feels almost counterintuitive because our everyday lives unfold on scales where the speed of light appears instantaneous. When someone switches on a lamp across the room, the light reaches our eyes so quickly that we perceive no delay whatsoever. Even sunlight, traveling nearly 150 million kilometers from the sun to Earth, takes only about 8 minutes to arrive, a pause so short that we rarely think about it. But the universe operates on distances so vast that those tiny delays accumulate into years, centuries, and eventually billions of years. The nearest star beyond our sun appears to us as it was more than 4 years ago. The Andromeda Galaxy is seen as it existed approximately 2.5 million years in the past. Some of the galaxies photographed by the James Webb Space Telescope are visible only because their light has been traveling toward us for over 13 billion years. Every increase in distance becomes an increase in age. Space and time cease to be separate ideas. They become different ways of describing exactly the same journey. Once that realization takes hold, the original question begins to change. Perhaps we should not expect to find the edge of the universe in the same way we find the edge of a continent or the shoreline of an ocean. After all, every observation depends on information carried by light, and information requires time to travel. No matter how powerful our telescopes become, they cannot reveal events whose light has not yet reached us. In other words, the limits of our knowledge may have less to do with distance than with time itself. It is a subtle distinction, but one that transforms the entire problem. The question is no longer whether the universe has an edge. The question is whether such an edge could ever be visible to us at all. Because before we can hope to discover where the universe ends, we must first understand where our ability to observe it ends. The idea that the universe might not have a visible edge is surprisingly new. For most of human history, people assumed that if they could somehow travel far enough, they would eventually reach the boundary of everything that exists. It was a perfectly reasonable conclusion. Every landscape has a horizon, every ocean has a coastline, and every map, no matter how detailed, eventually comes to an end. Our intuition was built in a world where everything occupies a finite space, so it seemed almost impossible to imagine a cosmos that behaved differently. Even after the invention of the telescope, this expectation remained unchanged. Each improvement in technology allowed astronomers to peer a little farther into the darkness, revealing new stars and new nebulae that had previously been invisible. The assumption was simple. If we continued building larger telescopes, sooner or later we would arrive at the outskirts of the universe itself. The only question seemed to be how long that journey would take. The first serious challenge to that idea arrived not through philosophy, but through observation. In the 1920s, the American astronomer Edwin Hubble spent countless nights studying faint smudges of light that many people still believed were clouds of gas inside the Milky Way. By carefully measuring their distances and comparing them with the light they emitted, Hubble reached a conclusion that permanently changed humanity's understanding of the cosmos. These objects were not nearby clouds at all. They were entire galaxies, each containing billions of stars scattered unimaginably far beyond our own. That discovery alone expanded the known universe beyond anything previous generations had imagined. Yet an even greater surprise was waiting. As Hubble continued his observations, he noticed a remarkable pattern. Almost every distant galaxy appeared to be moving away from us, and the farther a galaxy was, the faster it seemed to recede. This relationship, now known as Hubble's law, suggested something extraordinary. The galaxies were not simply drifting randomly through an otherwise motionless cosmos. Space itself was expanding. This was not an entirely unexpected idea. A few years earlier, the Belgian physicist and priest Georges Lemaitre had reached a similar conclusion using Albert Einstein's equations of general relativity. Lemaitre proposed that the universe was not static but dynamic, that it had once existed in an unimaginably dense and hot state before beginning a continuous expansion. At the time, the proposal seemed almost too radical to accept. Even Einstein, whose own mathematics naturally allowed for an expanding universe, initially resisted the implication. Believing that the cosmos had to be eternal and unchanging, he introduced what became known as the cosmological constant, a mathematical adjustment designed to keep the universe perfectly static. Nature, however, had no interest in preserving human expectations. When Hubble's observations confirmed that galaxies really were moving apart, Einstein reportedly admitted that introducing the cosmological constant for that purpose had been the biggest blunder of his life. Whether or not those exact words were spoken has been debated by historians, but the broader truth remains unchanged. Observation had forced theory to yield. The universe was expanding, regardless of how surprising the conclusion appeared. This discovery transformed the original question about the edge of the universe into something far more subtle. If space itself is stretching, then the universe cannot be imagined as a gigantic empty container through which galaxies are flying like bullets. A more accurate picture is to imagine the fabric of space gradually expanding, carrying galaxies with it. From every galaxy, the distant universe would appear to expand in every direction. If intelligent observers lived in another galaxy billions of light years away, they would measure almost exactly the same large-scale expansion that we do. They too would see distant galaxies receding from them. They too might wonder whether they occupy a special place in the cosmos. And they would reach the same conclusion we have. There is no evidence that any location enjoys a privileged position. Yet if the universe has been expanding for approximately 13.8 billion years, another puzzle emerges almost immediately. Intuition suggests that the most distant objects we should be able to observe ought to lie roughly 13.8 billion light-years away. After all, light has had only 13.8 billion years to travel. The real answer is considerably stranger. Modern measurements from missions such as Planck show that the radius of the observable universe is not 13.8 billion light-years, but about 46.5 billion light-years. At first glance, this sounds impossible. It almost appears to violate the very principle that nothing can travel faster than light. But the apparent contradiction disappears once we remember that light has not been crossing a motionless universe. While every photon was making its journey toward Earth, the fabric of space through which it traveled continued to expand. The galaxy that emitted the light billions of years ago has been carried much farther away during that immense span of time. The photon never exceeded the speed of light for a single instant. The distance itself simply refused to remain constant. This distinction is one of the most beautiful consequences of Einstein's general relativity. The speed of light limits how objects move through space, but it does not prevent space itself from changing. Expansion is not a cosmic wind pushing galaxies apart. It is the geometry of the universe evolving with time. Understanding this leads naturally to one of the most profound concepts in modern cosmology, the cosmic horizon. Every observation we make is confined within a sphere defined not by technology, but by time. We cannot observe regions whose light has not yet had sufficient time to reach us. Beyond that horizon, there may be countless additional galaxies, perhaps entire clusters and superclusters stretching farther than imagination can comfortably grasp. Their existence is not forbidden by physics. On the contrary, many cosmological models strongly suggest that the universe extends far beyond the region we can observe. What remains forever uncertain is not whether those distant regions exist, but whether any information from them will ever arrive. In that sense, the observable universe resembles standing on the shore of an endless ocean at night. The beam of a lighthouse illuminates only part of the water. The darkness beyond tells us almost nothing about what lies there. It is tempting to mistake the edge of the light for the edge of the sea, yet we instinctively understand that these are two very different things. One marks the limit of reality, the other marks the limit of perception. The same distinction applies to the cosmos. When people ask why we cannot see the edge of the universe, they often imagine astronomers searching for a distant wall, a final galaxy, or a place where space suddenly comes to an end. Modern cosmology offers a much more fascinating answer. The greatest boundary we have ever encountered is not built into the universe itself. It is built into the journey that information must undertake before it reaches us. Perhaps the edge we have been searching for was never a physical destination at all. Perhaps it is a reminder that every observer, no matter how advanced, experiences only a fragment of a much larger reality. Our telescopes do not reveal the entire universe. They reveal the portion of its history that has had enough time to introduce itself. And somewhere beyond that silent horizon, where no light has yet completed its unimaginable journey, the universe continues exactly as it always has, expanding, evolving, and writing chapters that, at least for now, remain forever beyond the reach of our eyes. Perhaps the greatest surprise in all of cosmology is not that the universe is unimaginably vast. It is that there are questions we may never be able to answer, not because we lack intelligence or because our technology is insufficient, but because the universe itself places a limit on what any observer can know. Somewhere beyond the horizon of the observable universe, space may continue for distances beyond imagination. There may be galaxies whose light will never reach us, stars that will forever remain unseen, and worlds whose existence we can only infer through the laws of physics. Whether the universe has an edge is still one of the greatest unanswered questions in science. But perhaps that isn't the most important discovery. Perhaps the more profound realization is that reality is always larger than the part we are able to observe. Every generation expands that horizon a little farther, not by reaching the end of the universe, but by learning to ask better questions about it. And maybe that is what science has always been. Not a journey toward certainty, but a journey toward understanding. Thank you for spending these moments with me. If you enjoy exploring the ideas that reshape the way we see reality, I'd be honored to have you here for the next journey. Until our next thought.